Actually, IEnumerable and IEnumerator are not comparable. Both are two individual interfaces, and one is not the alternative of other. Each has its own purpose and usage. But for a developer, it is necessary to understand both of these interfaces and when and how to use each one. So this lecture is about how to work with the IEnumerable and how to work with the IEnumerator. As you can see, both of these interfaces are the predefined interfaces, somewhat related to collections, but not only limited to collections. Both of these are for arrays also. See, first we will consider understanding about IEnumerable, then we can talk about IEnumerator. First of all, there is an interface called IEnumerable under the system.collections namespace. It has only one method called getEnumerator, which has return type called IEnumerator. The fundamental purpose of the IEnumerable is that to represent a group of elements. It can be an array, it can be any type of collection such as a list or array list, and even it can be collection of characters or anything else. But the problem is that the default IEnumerable interface is not generic interface, so it is not possible to specify the data type. That means it don't have any generic type here that is less than t greater than. So that is the reason, in order to provide the ability to have generic collection classes, there is an alternative IEnumerable of t, which is the generic version of the IEnumerable and which is the child of IEnumerable interface. That means this one. So the system.collections.generic.IEnumerable of t is the child of system.collections.IEnumerable. In other words, the generic IEnumerable is the child of non-generic IEnumerable. Even the generic interface IEnumerable also contains a method called getEnumerator, much like non-generic one. But alternatively, its return type is the generic type, that is IEnumerator of t. So overall, this generic version of IEnumerable is meant for representation of a specific data type, because of which you can specify any data type such as int, string or any other custom class while working with collections such as list, dictionary, etc. So all the other collection interfaces and classes are directly or indirectly the children of IEnumerable, as shown in the previous diagram. So as you can see, iCollection, iDictionary, iList, and the classes such as hashset, stack, queue, list, dictionary, etc. are the children of IEnumerable, which is ultimately the child of IEnumerable, which is the non-generic version. I did not draw a line from IEnumerable to IEnumerable of t to avoid the confusion, but actually IEnumerable is the parent of IEnumerable of t. But from now onwards, we are considering both of the interfaces as one for understanding the difference between IEnumerable and IEnumerator. So as you can see once again, inside the IEnumerable, we have a method called getEnumerator, which returns IEnumerator. So what is IEnumerator and how to work with that? We will understand it in a moment. Hold it please. First, let us work with the IEnumerable practically. I am creating a console application for a demonstration of IEnumerable. So we must import the namespace system.collections.generic. And suppose we have a collection, for example, list type of collection. And it has a set of string values. So list is a class which is the child of iList interface, right? In order to check that, you can right click on the list class and go to definition. So as you can see, list is the child of iList interface. And again, right click on iList, go to definition. So iList is the child interface of iCollection. And forget about IEnumerable of T and IEnumerable here, it's misleading. For clarity, please focus on the hierarchy. That is, iList is the child of iCollection. Again, right click on iCollection, go to definition. See, iCollection is the child of IEnumerable of T. And again, right click on IEnumerable of T and go to definition. So IEnumerable of T is the child of IEnumerable. And again, right click on IEnumerable and say go to definition. IEnumerable is the individual interface which is not the child of anything else. Of course, indirectly it is the child of system.object class. So as you can observe here, you can create the reference variable of iList or iCollection or IEnumerable in which you can store the address of this particular list object. That means you can not only create the reference variable of list type, but also you can make it as iList. That means system.collections.generic.ilist. And not only that, you can also make this as iCollection. So it works in the same way. But the point here is that since the reference variable is of a parent interface, that is iCollection, so from that particular reference variable, you can access only the properties and methods of iCollection type and also its parents. So if any methods are added in iList, those are not accessible through this iCollection. So what I am saying exactly is that from the reference variable of a specific interface, you can access only the properties and methods of the same interface and also from its parent interface, but not from its children. Anyways, since iCollection is the child of IEnumerable, even we can write IEnumerable here. The benefit of creating the reference variable for parent interface, that is IEnumerable, is that you can not only store the reference of list, but also you can also store the reference of any other collection objects, for example stack, queue, etc. Because those are the children of IEnumerable. And we can read and print all the values by using for each loop as usual. Here the data type of item variable is a string because it's a collection of string type of list, right? So as you can see, we are getting the same information by using the for each loop, but still the reference variable is of IEnumerable type. So if you are sure that you want only list, then you can prefer creating the reference variable of list type only. But you want the flexibility in the code. That means in future you want to change list to dictionary or something else. Then you can make the reference variable as IEnumerable type rather than list type. But still you can go ahead with the object of list class only, because later you can change it to some other type of object such as dictionary or something else. So we have successfully understood how to work with the IEnumerable practically. For example, you can store the list type of object, in the IEnumerable of t type of reference variable, and you can store the reference of object of array list type into the IEnumerable type of reference variable. Now let us focus on IEnumerator. So IEnumerator is not the child of IEnumerable, but it is an independent interface. IEnumerable actually uses IEnumerator. That means in the IEnumerable, it has a method called getEnumerator which returns IEnumerator object. The intention of the IEnumerable is that to represent a group of elements, so something multiple, something plural is the intention of the IEnumerable. But the intention of the IEnumerator is not for representation of multiple items, but reading through a set of elements. So whenever there are certain group of elements that is represented as IEnumerable, but going through each and every element one by one in a sequential order is the intention of IEnumerator. Do you know, the for each loop works based on IEnumerator. The for each loop by default starts from the beginning of the group, that means beginning of the collection, and goes through each and every element in a sequential order, right? Internally, it works based on IEnumerator. Actually, the IEnumerator has methods like move next and reset, and it has a property called current. So internally, when you use the for each loop for any kind of collection or array, it by default calls the reset method first, and every time it calls the move next method in order to go to the next number and assigns the value of current property into the variable that is declared in the for each loop. That means internally how does the for each loop works is that it works based on IEnumerator. In other words, if IEnumerator is not there, for each loop will not work. So whenever you use the for each loop, first it calls the reset method. That means the record pointer points to the beginning of the collection or array. And then it immediately calls the move next method. It returns true if any one element is found, but returns false if no element is found. So, because of the first call of the move next method, the record pointer points to the first element of the collection. That means element at 0. And that particular element at 0 position will be assigned into the current property automatically. And the value of the current property will be assigned automatically into the variable of for each loop. This is how the item variable gets the value from the particular collection. So at the beginning, a reset method is being called, and every time move next method will be called for each iteration. And every time the next value, that means the subsequent value, will be assigned into the corresponding item variable which is declared here. Of course, the variable name is not fixed though. So if you call the move next method second time, it points to the next element, and that element first gets assigned into the current property of the IEnumerator, and that current property will be assigned into this particular item variable. So all this process is just internal process. How does it work behind the scenes? So every time when you use the for each loop, the IEnumerator works. So as per the developer point of view, he may not notice the internal process, but the IEnumerator is the fact how the for each loop works. For clarity, to understand how it works internally, let me bring up the for each loop kind of alternative code. But in the real applications, you need not use that. You can practically stick to using for each loop only because it is preferred and easy. So for clarity, I am showing the code of IEnumerator just to understand how does it work internally. So first we can get the enumerator object from the collection. So since the list class is the child of IEnumerable type and it has a method called getEnumerator, and the getEnumerator returns an object that implements IEnumerator of string type. Here the data type string depends on the data type what you mentioned above. So directly we cannot create an object of IEnumerator type, but we can call getEnumerator method through which we can get the object of IEnumerator type. So at first we can call reset method, which puts the record pointer at the beginning of the collection. In that case, it doesn't point to any one specific element. And we can call the moveNext method, which moves to the subsequent element. So for the first time, it points to the first element, that is element at index number 0. That means in our example it is how are you. And we can access the current value by using current property of IEnumerator. So this prints the first value, that is how are you. So as you can see, currently we got the first value because only one time we have called moveNext method. This is how we get the first value. Then how about the next value? So next time when you call moveNext method, it points to the next element, that is the element at 1. And then the current property by default points to the current element, that is the have a great day. Like this, you can keep repeating these two statements in order to go through each element. So in this case, it prints thanks for meeting. So this is how the for each loop internally works. So in real world applications, you need not really write this type of code, but just for understanding how does the for each loop works, I have demonstrated this type of code. So only one time reset method is called. Every time moveNext and current gets repeated. It simply internally calls the moveNext method and assigns the value of current property into the variable that is mentioned here. That is, for example, item variable. But what about unlimited values? We are not sure how many values are present, right? So how many times this code should be executed? It should execute as many as the values are present. So in order to identify whether the next element is present or not, the moveNext method has a return type called bool. That means it returns true if the next element is found. It returns false if no next element is found. So instead of manually repeating moveNext and current, we can keep it in the while loop, because as long as the moveNext method returns true, the while loop gets repeated. But once the moveNext method returns false, it automatically stops. So because of the while loop here, we need not manually repeat that moveNext and current properties. As long as the moveNext method returns true, the while loop gets repeated automatically. That means the same code works for n number of elements in the collection. But still, the point is, for understanding the internal functionality of for each loop, we have learned this. But you need not use this type of code in the real world applications anywhere. So overall, the IEnumerator is made for making the for each loop work. But IEnumerable simply generally represents a group of elements. It can be an array or it can be any type of collection. So this is the conclusion of IEnumerator versus IEnumerable.